Hey everybody, in this module we're ready to meet our new equation, which is called a quadratic equation. Now it's going to be an equation, so it's still going to have an equal sign. But if it's a quadratic equation, its highest degree is no longer going to be the 1, because that would be a linear equation. So let's look at our definition. It says in our PowerPoint, a quadratic equation is written in the form ax squared plus bx plus c equals 0. And if you look very closely at the exponents, you'll see in the first term the exponent on x is a 2. So that means this equation is degree 2. Even though the next term bx, the exponent on x is a 1, remember the word degree means the biggest exponent. And if the biggest exponent in that equation is a 2, then we call this equation quadratic, which means it is not linear, so you do not solve it the same way. Now, in that equation where the letters A, B, and C are, there would be numbers, real numbers. So they could be positive, they could be negative, they could be whole, they could be fractions, they could be decimals. It is important that you're able to look at an equation and know whether or not it's quadratic, because that's going to tell you how to proceed to solve. I have 4 examples here of equations in the PowerPoint. Let's look at them. The first equation is x squared minus 4 equals 0. It is obvious when we look at that equation it has the x squared. So if it has the x squared, the exponent's 2, we know that equation's quadratic. The second equation, 5x squared plus 7 equals 28. We see the x squared. So again, that means that equation's quadratic. Now I know what you're thinking. You're saying, but Ms. Black, if I look at the definition says this equation has to equal 0. When you look at an equation, it does not have to equal 0 to be quadratic. We can look at it and know it's quadratic because it has that exponent of 2. Now, we're going to work with that equation in a minute and fix it so it will equal 0. But I want to make sure everybody understands, just because an equation equals 0 doesn't make it quadratic. The term that's making the equation quadratic is the x squared. If you look at the third equation, 9 equals x squared. That's quadratic. Even though the x squared's on the right side, it's still quadratic. It has an x squared. The last equation, x squared plus 5x minus 6 equals 0. So the moral of the story is, it doesn't matter how many actual monomials are in the equation. It doesn't matter whether the x squared's on the left or the right. As long as the equation has an x squared in it, and that's the biggest exponent, then we know we have a quadratic equation. Now, if you look at the PowerPoint, the next equation says x plus 2 in parentheses squared equals 8. And right now, by looking, that equation is not quadratic. Because if you look at that x inside the parentheses, it's understood to have an exponent of 1. So you can't tell me that equation's quadratic right now. But if you use your rules for simplifying, watch what happens. We all know our definitions. X plus 2 squared. Squaring means to multiply it by itself. So we would write x plus 2 times x plus 2 equals 8. And to multiply the binomial x plus 2 times the binomial x plus 2, we would have to do FOIL. So if I FOIL that out, I'd get x squared plus 2x plus 2x plus 4 equals 8. And we know when we do FOIL, the two terms in the middle are usually alike. We'll put them together. So now this equation is x squared plus 4x plus 4 equals 8. Now when we look at it in its simplified form, we see the x squared. So yes, it is a quadratic equation. So the moral of the story is, don't jump the gun. You can't tell me the equation's quadratic until you physically see the x squared. Now, here are some examples on the PowerPoint of equations that are not quadratic, and I want to make sure you understand why. X plus 3 squared equals 0 is not quadratic. I know we see the square, but is that exponent on the letter x? No, it's on a constant, a number. So just because you see an exponent of 2 doesn't guarantee it's quadratic unless it's on the variable. Because if you simplified 3 squared, everybody, what would that be? Correct, it would be 9. And that equation would be x plus 9 equals 0. And now if you look at the x, it's understood to have an exponent of 1. It's linear. If you look at the next equation, 2 times x minus 2 equals negative 2. Again, on the left side, if you distributed that 2, you would get 2x minus 4 equals negative 2. If you look at your variable x, there's an invisible exponent of 1. That makes that equation linear. My last equation, x to the negative 2 equals 9. Now everybody look closely. That exponent's a negative 2. And the definition of a quadratic is the exponent's got to be a positive 2. So I know what you're thinking. You're saying, I'll fix that. We've already learned how to make a negative exponent positive. We do the reciprocal of the base. So we take the letter x and we flip it. We do the reciprocal and we get 1 over x squared equals 9. And now you're going to tell me, Miss Black, the exponent's a positive 2. Well, you're correct. The exponent is a positive 2, but that x is in the denominator of a fraction. And if you go back to the definition of a quadratic, it's ax squared. That x squared is not in a fraction. It's not in the denominator. It's in the numerator. So the moral of the story is, to be a quadratic equation, your x squared's got to be in the numerator. It's got to be at the top. It can't be in the denominator. So that's why that third equation is not quadratic. Now that we know how to recognize a quadratic equation, now in the next module, we'll start solving them. See you then.